welcome back to another Dr. Z video. Before I go any further, I'd encourage all of you watching to comment down below on anything you're struggling with at school so that we can address your concerns. Today we are going to focus on the Year 8 unit of Everyday Chemistry. Let's get straight into it. So here are the outcomes that we're going to address today. Distinguishing between elements, atoms, compounds, and mixtures, distinguishing between pure and impure substances, distinguishing between physical and chemical changes, and then identifying the key properties of acids and bases. So firstly, with regards to that first outcome, there are elements, atoms, mixtures, and compounds that we need to focus on. So in terms of atoms, all substances are made of tiny particles called atoms. Now, an element is a substance that is made up of only one type of atom. So take hydrogen. Hydrogen is an element that is made up of atoms that consist of one proton and one electron. So, if you change the number of protons that atom has, then you change the type of element that it is. So for example, if you had 2 protons instead of 1, then you have the element helium and not hydrogen. So the number of protons in the nucleus is the defining property of an element, and it is referred to as the atomic number. So now we have compounds. Compounds consist of 2 or more different elements bound together, but are still just one type of molecule. They can be broken down into a simpler form by chemical means. They have properties that are different from its component elements, and they always contain the same ratio of elements. Let's take a very common example of water. So water consists, in regards to that first bullet point, water is oxygen and hydrogen bound together to form water, or H2O. Water can only be broken down by chemical means. It has properties that are different from its component elements, akin to hydrogen bonding, and its components are always in the same ratio. For water, there are 2 hydrogen atoms per 1 oxygen atom. And finally, there are mixtures. So mixtures consist of 2 or more different elements or compounds that are physically intermingled. So not chemically, but physically. And they can only be separated by physical means and not chemical means. Now, mixtures do often retain many of the properties of its components. In regards to that second bullet point about being separated by physical means, let's take the example of salt water. So if you boil salt water, the water will have evaporated, but the salt won't. So the substances have been separated by physical means. Physical means things like changes of state, in this case the act of boiling. So here's a very useful diagram on the right of your screen that can assist you in differentiating between what it is. So you can see elements are there, then mixtures. So you can see that mixture is composed of a compound and an element, but ultimately because they are there and they're physically intermingled, it classes as a mixture. So this is a pretty useful diagram to use. Okay, next we have pure and impure substances. So a pure substance refers to either an element or a compound. They can't be separated into other materials by physical processes. Now they will also have consistent physical properties. So melting and boiling points and others will not change. Now what do you think are impure substances? I'll give you 5 seconds to write down what you think it will be based on what I've just told you about pure substances. So, impure substances are mixtures. This means that these physical properties are not consistent. Now, it is important to understand that mixtures can be homogeneous or heterogeneous. I want you to consider and perhaps use the prefixes to think of what these particular words mean. So, homogeneous refers to having a uniform composition and like the same appearance, whereas heterogeneous are substances that are not distributed evenly. Think of some common examples. Homogeneous refers to like sugar water, whereas heterogeneous refers to like oil and water. Now, in the bottom right of your screen might be a bit hard to see, but I want you to notice that dichotomous key there and how it differentiates what we've just learned so far. So the number of types of molecule, there's just one. It's a pure substance. 2 or more, it's a mixture. Then if the number of types of atoms in the molecule, if there's just one, it's element. If there's two or more, it's a compound. Now, in terms of differentiating between a mixture, it refers to the distribution of molecules. So if there's an even distribution of molecules, it's homogeneous. If there is an uneven distribution of molecules, it's heterogeneous. And there are diagrams that accompany this. Now, physical and chemical changes. Matter will frequently change forms. Now, examining these changes of forms is at the heart of what it is to study chemistry. So, what exactly is the difference between physical and chemical changes? Well, a physical change refers to a change where the chemical composition of the matter is unchanged. Basically, as I mentioned earlier in the video, this often occurs through a change of states, and this process is reversible. So, you can get back the substance you started with. For example, if you froze the substance, you can get it back, so to speak, or the original substance may be acquired by melting. However, if you make an entirely new substance with new chemical bonds, that's a chemical change. Now, this process is irreversible. I'd like you to take some time to think of perhaps how you could detect whether something has undergone, or a substance rather, has undergone a chemical change. Well, here are the following signs you can use. The production of a gas, a change in temperature or color, the production of a solid, perhaps the disappearing of a substance, the formation of a solid, and perhaps most weirdly, a new odor. Now, on the right, I've put a diagram that details these changes. So as you can see, melting ice, shredding paper, chopping wood, and mixing grey and green marbles are all physical changes. On the other hand, a chemical change is where a chemical reaction occurs and where new products are formed. Burning wood, a rotting banana even, mixing vinegar and baking soda, and fireworks. And our final outcome of today is all about acids or bases. Now, I'm sure you've heard about this, and this definitely has a direct link with your daily life. So measuring whether a substance is acidic or basic is done using the pH scale. A substance which has a pH less than 7 is acidic, and one which has a pH more than 7 is basic. Of course, a substance which has a pH of 7 is neutral, the most common of this being distilled water. Now, it's important to note that bases which dissolve in water are known as alkali. Now, the pH scale is logarithmic. That means that each whole pH value below 7 is 10 times more acidic than the next value. What I'm trying to say here is that it's not a linear sort of scale. So say you had a substance which had a pH of 4 and one which had a pH of 5. So these are acidic substances, things like tomatoes, citric acid, lemons even, right? The substance with pH 4 is 10 times more acidic than that of pH 5 and 100 times more acidic than pH 6. So it's important to understand that the pH scale is logarithmic and not linear. Now, here are the key properties and examples of acids. They're corrosive to metals, they can taste sour, they change blue litmus paper red, and they're found in things in terms of its examples: hydrochloric acid, sulfuric acid, and lemon juice, citric acid. Now, the key properties of bases: they are slippery, they change red litmus paper blue, they are often used in cleaners, so many of the soaps you use at home are composed of basic substances, basic in this case referring to the fact that they have a pH higher than 7, and a common example is sodium hydroxide. Now I want you to figure out what happens when an acid and base combine together. Yes, they do neutralize, and neutralization is something we're going to focus on in our upcoming videos. But neutralization is a key process, particularly through the digestive system. Okay, ladies and gentlemen, that is it for today. I hope you've learned exactly what you wanted to learn, and until next time,